question. We are looking for the volume of the solid generated by the spinning of the area contained by these three graphs in the coordinate axis.
There's the graph of g of x. And next in green comes the graph of f of x. And finally, in red, comes the graph of h of x. And the area being shaded in is the area we're about to spin over the x-axis. But first we need the points of intersection. P1, which occurs when f of x meets h of x, P2, which occurs when f of x meets g of x, and P3, when h of x has a 0. For now, we're going to break this region into three smaller regions, from 0 to P3, from P3 to P1, and from P1 to P2. We can now use our calculator to plot the three graphs, and then determine at what coordinates these functions have points of intersection. We've already determined the points, but we'll show you how to do this on our calculators. First we will find P1. Hit second calc and choose the intersect option. And then choose the two graphs. And there's P1. Now repeat the process for P2. And there's P2. Now we're looking for the root of h of x. So go to second calc, 0, and find the 0. And there's P3. And now comes a massive chunk of algebra to solve for the volume of the solid. We're now going to take our three regions and revolve all three around the x-axis, and in doing so, factor out pi. The first region is given by g of x squared on 0 to P3. The second term is given by g of x squared minus h of x squared on the interval P3 to P1. And our third term is given by g of x squared minus f of x squared on P1 to P2. The rest is just pretty much crunching numbers. And this is our final answer. We've determined that the volume of the solid generated is 46.8451 units cubed.